We're going to talk a bit today about the challenge of optimizing vehicle location. So first of all, nice to meet you. My name is Jesper. I'm a machine learning engineer at Void Technology. And on a daily basis, I work with different types of machine learning problems that are related to the different needs our vehicles might have on the streets when users are not riding them. To give a bit of background about Voi, Voi is a micromobility company. We're aiming to create cities made for living, that is, cities made for people and not cars. We do that today with shared vehicles, both e-scooters and e-bikes, all throughout Europe. To put that into some numbers, Voi was founded in 2018 here in Stockholm, Sweden. Not everybody knows that. But since then, we've had quite a journey. We're today around 900 employees. We have about 100,000 vehicles in operation, and those are two modes of transportation, shared e-scooters, and also shared e-bikes. And those vehicles have had about 240 million rides since the start of our operations across 100 cities. You can see those to the right here on the map. And estimately 36 million car trips are replaced. And with all these vehicles and all those millions of rides, millions of users, it's pretty safe to say that the balance of our fleet is constantly changing. Vehicles are moving all the time, users are riding pretty much all the time, and that has some pretty big implications. We really need to keep track of that and treat that problem in a very structured way, in a smart way. But one of the first questions I wanted to kind of think about here is what would happen if we would never relocate our vehicles? We just let our users take their trips and we don't care about where they end up or where our user would like to ride them next time. So it could kind of look like this. Let's say you have a user that are on their daily commute from up in Vasastan down to downtown Stockholm. They usually take a Voi in the morning and when they go to work. But then after they have wrapped up their work for the day, they might go to after work in the evening with a few friends, and by the time they want to go back home, they take a bus or a taxi, for instance. So what does that mean for our vehicles in this case? Well, we might see something like this, where vehicles are all of a sudden just clumped up in some areas, some busy areas where people like to end their rides. And when the user wakes up the next morning and they want to take the morning ride to work again, the vehicles aren't there. So the fleet is heavily imbalanced and doesn't meet the demands of the users. And not only is this, as you can see, the user is very, very sad, the user might also lose trust in our service and eventually churn because they don't think anymore that they can find any Voi vehicles when they want them. So obviously we will need to relocate our vehicles to some extent. And this is not only a problem for our riders. If we decide that we want to move vehicles on some schedule, the people who are in charge of actually moving them, our in-staff personnel, they would need some sort of guidance. We can't just say to them, so you're going to move a couple of vehicles today, do your best, hopefully it works fine. They would have to need some sort of guidance. And if we would just put that on market operations staff at HQ or somewhere else, if they were in charge of doing that relocalization strategies, that would be very time consuming. And without any kind of automation, they would also need some really deep local expertise of the cities. If one person is in charge of figuring out where 100,000 vehicles are going to be located across 100 cities in Europe, I mean, it's impossible. So there are a couple of problems here to address. And this is very important to solve for a couple of reasons. So both in terms of availability for our users, like I said, having a vehicle nearby is the most popular or the most important purchase criteria for any micromobility user. I mean, if you can't find any vehicles where you are, you have nothing to ride. So you don't need to care about our service anymore, right? So not only in order to meet demand from our users and keep them happy, but we want to keep our users in our service for a long period of time as well. But there's also another aspect. So we're not only serving riders, also serving cities that we're in. And with local rules and regulations of the amount of allowed vehicles in certain areas, we need to make sure that our fleet is compliant with that. You could imagine an area in downtown Stockholm that there might be a cap of how many vehicles are allowed to be there at a given point in time. And if we breach those regulations, as we're not moving vehicles around, I mean, city's not going to be very happy, and we might risk not being allowed to be there anymore. So both for riders, but also for the cities, this is a super important thing to get done right. And it really just comes down to supply and demand. If we can understand the supply of where in the city are we expecting our vehicles to be located, while also understanding the demand side of where in the city are our users going to want to ride Voi vehicles, then it's just a matter of moving vehicles from a very low demand and high supply area to a very low supply, high demand area. It sounds simple when you put it like that, but it's not that easy. But just to put into some context on how to think about this problem and the kind of different ways we think about it. Let's say you have a vehicle outside of this lovely, lovely office. Pretty much today, 6 p.m. on a Thursday. How likely is it that this vehicle would get a ride? I mean, people are in the city for work. They maybe around this time they want to go home. So you might think that, well, given the time of day, it's pretty likely that someone would want to take this home. Also, beautiful weather outside. But if we would change that day a week to a Sunday, it becomes a whole different picture, right? So people are going to be more at home, at least not in the office. And this vehicle is probably just going to stay there until maybe the next Monday when people are back in the city. So time of day and day of week is definitely like important signals to consider here. So what if we then just absolutely nail those two and we say, okay, 6 p.m. on a Thursday, it's not a public holiday, which would turn that Thursday back into a Sunday again, and we don't want that. And if we also know that vehicles in this spot at this time, historically, so 6 p.m. Thursdays back in time, if we know that those are quite likely to get rides, can we say the same for this one? I mean, of course not, because we live in Stockholm, Sweden. The sky might just open up and heavy rainfall is pouring over this poor vehicle. And that's another thing that we really need to consider. Things such as, what's the weather going to be? What's the battery life of this vehicle? Are people going to not want to take the risk of this vehicle dying on the way home? What kind of signals are characterizing this particular location? Is this a business district, residential area, location to public transport, etc. So just to give you an example of the different types of signals that could matter here, things you really need to consider if you want to get this right. And as you probably can tell, it's really challenging to just guess the expected probability of vehicles getting a ride just based on some manual analysis. If you take all of those, time of day, day of week, weather, battery life, location, and so on, you would try to sit down for each and every vehicle or even try to run some sort of arbitrary logic on top of that, that's going to be super hard. Because there are really complex patterns here between multiple signals, and you would definitely need some type of high degree automation in order to do this every single day, multiple times. While it might not be a suitable thing for someone to do manually, it's a much better case for machine learning. So that's what we're doing at Voi, but I want to talk a bit about the challenges of that. Because just saying, oh, if you just predict supply, just predict demand, and just rebalance according to that, then it's all fine. But there are definitely some things that are making this a not so easy task to solve. Just as a starting point, getting ground truth in any kind of label. How do you know how many rides a vehicle would get if we moved it to a new location? We haven't moved it yet, so we can't really say for sure. And there are so many different things that are happening at the same time, so it's really hard to understand that. So one of the most simple things in any machine learning problem, just getting the label already there, it's definitely a challenge. And also related to that, if we know how many rides a vehicle got if it were placed in one location, let's say we have a spot outside here, there are 3 vehicles there already, and we put a new one there. That new one gets 20 rides in the following days, and we're going to say, well, that's perfect. That was a great drop of a vehicle. But in reality, maybe those rides were just taken from one of the already existing vehicles. And how do you quantify that? And how can you really understand that in some kind of metric or label? Also, with 100,000 vehicles and thousands of vehicles in each city, there's a constant inflow and outflow of vehicles and riders happening. Demand is always shifting, supply is always shifting. A vehicle that might seem to be in a good spot at 8 a.m. in the morning in the commute rush to work, a few hours later, it's worthless if it's in a residential area. And same, vice versa. If it's in the city, having that in the morning might not make that much sense, but around this time of day, much better. And how do you quantify that? And how can you really understand and describe those flows of the cities? It's a bit of a challenge as well. We're also limited by how many vehicles we can move during a shift. At the end of the day, these are our colleagues that are out on the streets moving vehicles around, and they don't have infinite space in their vans. They don't have infinite time during their shifts. So we need to make sure that they are doing the most valuable relocalizations that we can calculate. But even if we know that these are the most valuable vehicles to move, there might also be policy and city regulations that we need to comply with. So we might have an area where we say, this is going to be the perfect spot to put a new vehicle in, but it's already at its max capacity according to some city regulations. So we're kind of blocked from doing that. Also, just the pure optimization between cost and value. It's going to cost us money to visit a new vehicle, put it in a van and drive it to another location, but there's going to be some value associated to that as well. If we think that this vehicle is just going to stand still for multiple days or something, it's not going to give us any value whatsoever. But if we put it in a really busy area at the right point in time, it's a different story. It's hopefully going to generate us money. So the balance between that cost side and the value side is also super, super important in order to get everything right. And also a bit similar to Florian's talk, just the scale of things. Millions of users, 100 cities in our case. We really need to make sure that this is working well across the board. We can't just look at outside in Stockholm and say we're doing great, look at a map of Stockholm and understand those drops perfectly fine. We need to make sure that this is working in London as well, in Oslo, Berlin, and so on. So just to give a little bit of a highlight or high-level introduction on what we're actually doing today. So for all of our different cities that we have in place, we are running continuous runs of our predictions during the day and for all different cities. We have two different kinds of models that we're running. One model that's responsible for the collection of vehicles, so which vehicles should we pick up from their current location, and also a drop model that will decide, so where should you put new vehicles. These models are then going to output different lists of vehicles. This is the value of moving these vehicles. This is the value of putting vehicles in these locations, and then we can rank them. And depending on what the capacity is of moving vehicles at the moment, then we can select the top X vehicles to move to the top X nodes to put vehicles in. And just to talk a little bit about what happens with that output. So it's not us just crunching some numbers and we're good for the day. We're actually sending these to the app that our in-field staff is using in their operations and their work. So you might be familiar with the usual Voi app, where you guys hopefully are taking multiple rides. But our in-field staff is having their own app where they can see all the vehicles that need to be moved. They can see all the nodes where they should put the new vehicles. So we're working directly towards that app in order to display those vehicles as soon as we have the predictions. So with that in place, our in-field staff has super clear guidance what to do during the shifts. Our HQ staff can spend much less time thinking about where each vehicle should be located and more time on hopefully more valuable things. And also really important, our riders can have vehicles nearby right when they need one, no matter where they are. So the next time you go outside here in Stockholm and you see a Voi scooter on the street, try to think about what causes it to be in that location, because probably a pretty good reason for it. Thank you.
Very good talk, thank you. Just a question regarding the policy regulations, not so much about the models, but more just how it works. Are the regulations shared between companies, or because there are many kind of competitors to you? So let's say, are the regulations that this spot can at most have X number of scooters, or is it like your company can max have X number of scooters there? Is there like a battle between companies to place it there first, or do you kind of, yeah?
Right. So it's not a battle of, we don't really in our solutions take into account like we need to get there first, so nobody else has time to do it. I'm not exactly sure about the exact details of all the regulations. That would be more on the policy side of things in those teams. But that's at least not something we take into account on our side.
Okay. Thanks.
Thank you. Really nice talk. I was wondering, like, how do you test new model? Because do you test them like, because you have like these two models which have like interdependent to some extent. Like, do you ship new iteration of both models at the same time, and or like one after the other? And like, how do you test the efficiency of a new iteration?
Right. So in terms of are we working on both of them at the same time? It could be that it depends, right? If we what we kind of observe in performance as well. If we see that we are doing absolutely great on collecting vehicles that we think are the most valuable to pick up, but we might not put them in the best locations, then of course we're going to focus our efforts more towards that drop model. So it kind of depends on that where we see the needs, but they're kind of, even though they are working sort of together to solve the same problem, they're actually kind of decoupled as well. Exactly which vehicle you're picking up is not super dependent on where you can drop vehicles. It could be, ideally it could be, you could just guess on vehicles to pick up, but then you could have really good places to put them. So it's not that this vehicle is going to this location exactly, it's just this is our vehicles that we need to pick up, and these are really good place to put vehicles in general.
Yeah, I was wondering about, because you have other logistic operations here as well. For instance, you have the whole battery issue that you send people around to replace the batteries in situ, I believe, right? I wonder if that is that integrated so that these are the same similar teams performing these tasks, and if so, can you optimize for like, okay, we need to visit this one because it's flat, then we can also transport it, or is these entirely separate?
Yeah, so in terms of who's working on what, it's a bit different. It's still within the kind of realm of operations at Voi, but on each specific kind of task that you can do on a vehicle, it's a little bit different, but we own a lot of it. But of course, there are massive efficiency gains of just having multiple needs on a vehicle. You can do all of them at once. You don't have to have one person going there to move it, another one there to swap the battery, and another one to just move it a little bit because it's not inside of a parking spot. There are definitely some big gains there, for sure.
Yeah. Thank you.
Thank you. Great talk. I actually have a question. You mentioned about, so when you, for example, evaluate like, okay, where do we see trends? You use like historic data, like is it a Sunday and so on. But do you actually also use like dynamic events which are in the future for like predicting these models? Like for example, if there's a concert coming up or like a football match, something that would not be like visible in historic trends because it's a one-time thing. Is that something that you take into account?
I mean, in terms of exact signals and exact it's this very thing, can't really comment on too much about that. But of course, like that is going to affect what the city looks like. If there's a major event that a lot of roads are blocked off and you can't really ride anywhere except for the specific road, that is going to have an effect on the problems. It's definitely something to look at. I think those things could be taken into account in a couple of different ways. This is a central solution that is supposed to work for a lot of different cities. So taking all of the local nuances into account at once can be a challenge, but it could also be solved with very close collaboration with the local teams that are experts on their individual market. So they can flag, we have this big thing coming up. Maybe we should change some things about how this model is working in our city at the moment. And that could be one way of doing it.
Cool, thank you.
What's the actual quantities that you predict, and if you can tell us, like, I mean, if it's probability of being picked up tomorrow, and how did your team reason when you decided on which quantities to work with?
Yeah, I mean, I can say that we've tried a couple of different things. Probably not going to say exactly what we're predicting at the moment, but I mean, it comes down to some sort of, like, the demand is going to be rides and the supply is going to be vehicles to some extent. And those are related in a bunch of different metrics you could look at. But on the exact label that we're using, I'm probably going to keep that internal for now.
Okay, good choice.
Maybe just a question for me. What kind of like a stack do you use, tech stack, to deploy your models, run them, train them, etc.?
Yeah, so data warehousing is on and storing data. That's a lot of Snowflake. So that's pretty much where we're getting a lot of the data from. We're using Google services pretty much across all the company. So a lot of their services for ML as well.
Thanks.
Yeah, could we look at the slide where you presented the two models?
This one?
Yeah. So one of them is collecting model, and yeah, so one is demand and one is supply, right?
Pretty much, yeah.
Are these two interacting in some way? Because this, like, the demand and supply situation is changing in real time, and then also like these trucks, they have a certain capacity and they pick up some scooters, then some more in another location, then some more, and on the way they're also dropping them off. So the capacity of the truck keeps changing. How are there any interactions for that you factor in?
So for a large extent, they're pretty separate. There's some optimization happening around this stage. But for the most part, we're keeping it pretty split. So if we can figure out which vehicles are in kind of the worst state where they are right now, and what are the best places we could have vehicles, if we can just move those, then we don't need to really couple them too tightly either. And this also creates a lot of independence and flexibility. In practice, we could just swap out a type of model that we're doing for one of them and keep the other one running the way it is, which is also really nice instead of trying to solve both in just one single pipeline pretty much.
Yeah, makes sense. Thanks.
I couldn't see the... Yeah.
Sorry.
That's all right.
Thank you. Great talk. I was wondering, in terms of routing, is that something that you're working on, or is that sort of more up to the operators, I guess, to decide on when I should pick up or like optimize that flow?
So our team currently is mainly focused on the needs of the vehicles. So location is one of the needs. Batteries could be another need, for instance, or just if it needs to be reparked in some way without being moved from a different part of the city to the other one. So what happens is that we push this information through this app, and then the kind of process of executing that is not really up to our team. So that's not something that I'm working on directly.
Thank you.
Is that it?
Nice. Great. So thank you very much. Maybe a round of applause for Jesper and also from Flora. So we finished a bit earlier, but you know, if there's still some wraps and drinks, just feel free to grab some and have a bit of a chat. You know, that's it. Thank you so much for coming.